Okay, welcome back. Now, looking at perpendicular lines, before we jump to examples, we need to understand what perpendicular lines are. For anything to be termed as perpendicular, for something to be called perpendicular, their meeting or their intersection must yield an angle of 90 degrees. For example, if I have this line as coming from P to Q, what is perpendicular to this line must form 90 degrees with this line. So once we get 90 degrees here, this means this line and this line are perpendicular. But the moment we have a line like this, maybe P to Q, and we have a line coming like this, and this angle is not 90 degrees, this line cannot be perpendicular to the other. So for two lines to be perpendicular, they must meet and form an angle of 90 degrees. So when we look at them meeting and forming an angle of 90 degrees, this sums up the lines being perpendicular. So if we have two perpendicular lines, and one having gradient, let's say M1, and the other having gradient M2. Remember we say for lines we compare gradients, and we do give them terminologies depending on where the gradients will fit. Now, these lines, the two lines, form an angle of 90 degrees. So to look at a scenario under these lines, or under coordinate geometry, it is always easy to remember that for two perpendicular lines, the product of their gradient must be -1. That is to say M1 times M2 must give us -1. Or one is the negative reciprocal of the other. For instance, M1 is the same as -1 out of M2, which is negative reciprocal. When I talk about reciprocal, I mean one changing its location. The one that is the numerator becoming the denominator, and the denominator becoming the numerator. So that is one thing about perpendicular lines that you should know. That whenever we multiply the two gradients, that is M1 times M2, the result must be a -1. The other ones would say for parallel lines, M1 must be equal to M2. But in case of the perpendicular lines, the product of the gradient must be -1. That is to say M1 times M2 must give us -1. So this is the scenario or the assumption we're going to move with. So when we look at question 1 as our first example, and it says find the equation of the line passing through the point, and this is the point, and is perpendicular to the line joining to the line y equals to -3x. And then there is also a 2. So we have a line. These lines are perpendicular, meaning they do meet and form an angle of 90 degrees. So they say find the equation of the line passing through the point. So there is an equation of the line. Let's say it's line 1 with gradient M1. And so it passes through a point, and this point is 2, -3. That is where it passes. So they want us to get the equation of this line. But then they say, and it is perpendicular to the line. So this is the perpendicular line, which forms an angle of 90 degrees with the initial line. And is perpendicular to the line y minus 3x equals to 2, which means this line is given in its equation form, which is y minus 3x is equal to 2. What does that mean? This second line will give us gradient M2, and this one will give us gradient M1. So we need to know, can we get gradient M1? We can know gradient M1 if at all we know gradient M2. Remember we saying the product of the gradients is equal to -1, which is M1 times M2 must give us the -1. And so this is a very simple scenario. When we look at this, we can get M2 from here, knowing that y minus 3x is equal to 2. Looking at the general form of an equation, it is y equals to mx plus c, which means this value of x must come this side of the cosine. So y is equal to 3x plus a 2. That is our normal equation. So comparing it with y equals to mx plus c, we come to realize that our m2 is equal to 3. And now since m2 is equal to 3, we can get m1. So we easily say that from M1 times M2 being equal to -1, which means M1 is equal to -1 out of M2. So M1 is -1 out of 3. So the gradient here is going to be 1 out of 3. So like we've seen in our previous sessions, yeah, we've got the gradient and we have a known point, which means what they want us to get is the equation of this line, but we have its known point and we have its gradient. So we don't waste a lot of time, we get the value of the intercept, knowing that we are concentrating on a line which is 2, -3, and it has got its gradient as -1 out of 3. So knowing that y is equal to mx plus c, and so y is -1 out of 3x plus c, then we substitute the values of x and the value of y. Remember we said coordinates are in the form of x and y. So we can easily come and say -3 is equal to -1 out of 3 times 2 then plus c, because this will have to come this side. So this multiplying here is going to be -9 is equal to -2 plus a 3c. So this comes the other side and it's going to be added on the other one. So there is a reduction. So -7 is equal to 3c. So my value of c is -7 out of 3. And this means I can easily assemble the equation of this line, knowing that it's going to be y is equal to mx plus c. So my x is -1 out of 3 x, then plus my c value, which is -7 out of 3. So this becomes the equation of the line that is perpendicular to the line that we were given initially. So that gives birth to the solution of our first example. Looking at our second and the very last example, which says find the equation of the perpendicular bisector of the line joining x and y. So there is a line, what we call a perpendicular bisector. Now a perpendicular bisector is always a point or a line, but this line will always divide a line into two equal parts. When we talk about a bisector, let us assume this is A and this is B. Now this line will have a bisector, but the perpendicular bisector, which is in that form, will divide these into equal points or equal lines, which means the distance from here to here is equal to the distance from here to here. Now this is what they call a perpendicular bisector. It divides the angle into the line into equal parts, but with a known angle of 90 degrees. That is what we call a perpendicular bisector. Now in this scenario, they told us find the equation of the perpendicular bisector of the line joining x. So if we have here x and our point is 8, -9, and then the other point is y, which is 4, 7. Now they want us to get the equation of the perpendicular bisector, which is this. This is what we call the perpendicular bisector. Now, in order to get an equation, we must have two known points, and with the two known points, they must feature on the line. Now we are having a line that has got no point. We need to first get a point on this same very line. So how can we get a point? This line is a bisector, and it divides this line, the initial line, into two equal parts, which means we can get this point here. This point where they do intersect, we believe it is the midpoint of the line from x to y. So we can first get the midpoint, and the midpoint, like we saw in our previous lessons, midpoint is given as the x value being added divided by 2, and then the y values being added and then divided by 2. So the midpoint here will be 8 plus a 4 divided by 2, comma, -9 plus a 7 also divided by 2. And so this is 8 plus 4, which is 12, divided by 2, which is a 6. This is a 7 minus 9, which is a -2, divided by 2, which is a -1. So this point here appears on this line and at the same time appears on that line. That point is here and it is 6, -1. It is a point on this line, at the same time it is a point on the perpendicular bisector. So after getting those points, you can continue and come up with our solution in our exercise very fast. When we continue with our example, getting the equation of the perpendicular bisector, now we have something different. We have point x to y, and then here we have 8, -9, and this is a 4 and a 7. So we shall have here a point. Let's say it is point A, and we say this point is 6, -1. So this point is on this line, at the same time it is on this line. But this initial line can have gradient m1, and this one will have gradient m2. Remember, the two are perpendicular, or they form an angle of 90 degrees. And we've said when we have two lines perpendicular, the product of their gradient is -1, meaning m1 times m2 must yield -1. But we cannot get this before we do get the values of either m1 or m2. But we can get the value of m2 since we have the visible known points that we are given. So m2 is going to be the change in y out of the change in x, which is y2 minus y1 out of x2 minus x1. So m2, gradient m2 will be my y2 is here, which is a 7, minus my y1, which is -9, divided by my x2, which is a 4, minus 8. So my m2 is going to be, this is 7, and then it adds, so it is a 16. And the 16 is divided by, it is going to be 16 divided by -4, which gives us the result as a -4. So knowing that the value of m2 is -4, so we can get the value of m1 from m1 is equal to -1 out of m2. This gives us the answer. We say the result of the negative reciprocal. So m1 is going to be -1 divided by -4, whereby these two become positive values. So my m1 is going to be 1 out of 4. What does this mean? We now have the gradient of this other line. So, since we have the gradient and we have one known point, which is point A, and it is 6, -1, with the gradient m1 given as 1 out of 4, we can easily look at the equation of this line coming from y equals to mx plus c, knowing that my y is, we say the m is the gradient, so it is 1 out of 4x plus the value of c. So we can now substitute for x and y, knowing the first coordinate is x and the second one is y. So I will have -1 is equal to 1 out of 4 times 6 plus c. So by 2 by 2, 3. So 2 cannot divide anymore, so I can multiply the 2th route. So it is -2 is equal to 3 plus 2c. Taking this the other side, it is -5 is equal to 2c, making the c to be -5 out of 2. Now this is the value of c. From the value of c, I can easily assemble and come up with the equation of the line, knowing that my y is mx plus c. So my y is my m, the value of m, in this scenario is 1 out of 4x, plus the value of c, which is -25 out of 2. And that becomes the equation of the line. And that means, that is the idea we use in